In our previous example, we had this function called func, and it didn't take any arguments. It was about as simple as a function can get. But let's see what happens if we pass it some arguments. So first, let's maybe make a function that is more likely to have arguments. Maybe let's do a and b, and we will add a and b together, and we can return the result. And let's just print a plus b as well for fun. And let's make sure to call add here. So you add 1 plus 2, save and run. Okay, so this is interesting. We got an error called add 1 plus 2, but we get the error that wrapper takes 0 positional arguments, but 2 are given. Now this makes sense if we look at our code, because we passed 1 and 2 here, but this add is really, if we remember, it is the timed add, if we will, equals timer passing an add. And this timer passing an add returns this wrapper. So if we were to call wrapper, notice it doesn't take any arguments. So in order to get the arguments through wrapper into the actual function called we need to pass in all arguments, and for completeness, all keyword arguments. Now let's see what happens. Nice, new error. We're getting closer. So now our wrapper took the right arguments, but you notice that func, when we call func here, didn't get the right arguments. And this is because we didn't pass these through. So we still need to pass these all the way down. And now if we run this, it works. Perfect. So now the arguments we pass in here get passed through wrapper, because when we add a decorator, it's the same as defining a function like this, basically defining a new function that is wrapper. And we have to pass in any arguments that were given here through to the inner function. So for example, if this also had a optional value c, let's say, and we did c, maybe c is 0 if not provided. And in this case, we provide it as a keyword argument. So let's do c equals 10. This should still work, and it does, because we have these keyword arguments also getting passed through. So whenever you're doing decorators, always make sure to just pass through all arguments you're given in this wrapper function all the way down to the function actually being called. So what's next? Well, we've done about all we can do with this basic setup, and this is really useful in a lot of instances still. But there's more we can do with decorators. So keeping with this timer functionality we've built up, let's see if we can add the ability to customize this timer decorator. And this is where being able to provide some parameters to our decorator comes into play. So let's just see what happens if we were to do this right now. Well, maybe we want to make our timer print the time but show the units. So maybe we can do a string here, and inside we can show the actual units we want. So let's do, let's call this units, and let's wrap this as well. And something there, perfect. So let's just run that and see what happens. Units not defined, of course not. So let's make our units default to seconds. Okay, perfect. So now we get 7 times 10 to the negative 5 seconds. All right, let's get rid of that. But say we want to customize this. How do we get information into this decorator? Well, if we look at this syntax, it's important to note that whatever comes after this @ symbol needs to be a decorator. And a decorator, as we defined earlier, is a function that takes one argument which is a function, and then returns a new function that wraps the function we passed. So that's what we already have set up here. So with that, how might we generate a decorator and turn it into this timer here? But at the same time as we generate that decorator, we pass in some arguments to it. One thing we might do is make a new function called Timer Generator. And let's put our timer decorator inside and return it. Okay, and let's comment out this code here. And let's just go back to how we know decorators work originally. And the way they work, when we think about it from not using the @ syntax, but actually defining them, how Python does behind the scenes. We could now first make a timer, call timer generator to get a timer decorator, right? Because the result of this timer generator call is this timer function, which has the form of a decorator, as we already saw in a previous example. So we could do this, and then we could use this decorator and pass in our function, and this would be timed add again. And now we could do timed add 1 + 2. Let's comment this out. If we run this, we get what we got before. But now we've introduced this extra step. It doesn't do anything currently, but now we have a way in to pass data, because now we have an outer function, and with any function, obviously, we can pass in information. Now, if we want to add some extra functionality, we can pass in an argument here, units, and let's just pass this all the way through. So the units defined here should show up here. And if instead we pass in our seconds here, let's remove this. And now we see we get the output that we expect, 1 + 2, and the time it took. Great. So this is super interesting. Now we can pass in any number of arguments here. We can pass them down into our wrapper function. So we get a custom decorator. So now let's call this timer decorator seconds. So we know what it is. And let's make another one. And maybe this one will be called milliseconds. And we can change the units. So now we have a timed add, and let's call it timed add seconds. And maybe let's do timed add in milliseconds as well, using our separate generator, because this one is returning a new function. So let's do timed add seconds here, and timed add in milliseconds. Let's see what we get. Look at that. Now, the first case we got our seconds, and the second case we got our milliseconds. Now, obviously, we didn't do anything to actually change the calculation here. We're just passing through a string. But we have two different generators working. And we pass in the arguments for one. We get a generator that outputs the units in seconds. And the other one outputs the units of milliseconds. Now, if we think back to what that means to defining a decorator using this @ syntax, all we have to do is generate a new decorator before the @ syntax. And we do that by the same way we did down here. We can define it in seconds. Let's just comment all of this out for now. And let's call add 1 + 2. And see what we get. Of course, we forgot the units. Nice. There we go. Now, this is super interesting. So if we break this down, kind of separate this a little bit, this timer generator returns a new decorator that has units set to seconds. Then that is handled by this at syntax, which does the assignment behind the scenes to pass in the function add to our decorator. Now this is super interesting and super powerful because now we can customize the behavior of our decorator, because every time we're generating a new decorator that's going to be applied. And in practice, what we want to do is, instead of calling this timer generator, we would just call this timer, because we just want it to be the normal name of the decorator that we're using. And at least what I like to do, and I think is fairly common practice, is to call this the outer function and call this the inner function. And this just helps avoid having to worry about naming things, because we all know naming things is hard. So here, let's just return outer and return inner. I like this because it always reminds me that I need two functions. I need an outer and an inner that are defined inside my decorator. So now we can go back to what we had originally with timer, but now timer takes an argument, and let's run that. Yeah, look at that. Maybe let's change this to milliseconds and run it again. And we have milliseconds. Perfect. So what's interesting here is that if we leave off this call and save, what happens? Outer takes one positional argument, but two are given. And this is weird, because what does that mean? Well, it's because if you don't call this timer function, we're not getting back a decorator. We're just passing it a function that isn't expecting a function now, it's expecting units. And that's going to throw off how Python handles things behind the scenes. Because you can imagine down here, we have to remember, when we call the function, we always want to get back a decorator, and that is what we're applying to the at syntax. So if this didn't take any arguments, and we just said units equals s to hard code it again here, and we tried to run this, it would still fail, because we would have to call it, because what we want is this. This is the decorator here. So let's try that again, and there we go. So this is just something to keep in mind. Now we can get around this, and I'll cover that probably in the next video, on how you can check based on if there are arguments or not passed in, to allow you to call kind of a naked decorator, if you will, or define a naked decorator like this, where you don't have to call it, just so you avoid these types of errors in your code, because this can be kind of annoying. Sometimes it's nice to be able to pass arguments, but if you don't pass them, to just define it like this and not have to actually explicitly do the open and close brackets. So we can cover that next video, but for now, hopefully this showed the kind of basics of how to pass arguments into a decorator, and also how to make sure to pass your arguments through the wrapper function of your decorator all the way down, so that you can add decorators to functions that take arguments. So args all the way down. Thanks very much, and hopefully you enjoyed this video, and I will see you guys soon.